So today we're going to be looking at converting rational numbers to decimals using long divisions. So we're going to be changing these fractions into decimals. And I've already worked a problem out here for you. And this is to show you the repeating decimals. So, can we find the decimal form of 1/6 by writing it as an equivalent fraction with only factors of 2 or 5 in the denominator? So that was kind of the bonus work that you may or may not have done yesterday. Either way is fine, but I'm going to use long division instead for this problem. So we've got 1/6. Send this number out, and then the 1 just falls down when we're setting that up. A lot of people have trouble, sorry about that, a lot of people have trouble just setting the problem up initially. So whatever is in the numerator, it just falls down, and then that kicks out the denominator. So how many groups of 6 are in 1? 0. How many groups of 6 are in 10? 1. 1 times 6 is 6. I subtract that. 10 minus 6 is 4. Bring down a 0. How many groups of 6 in 40? 6. 6 times 6 is 36. When I subtract, I get 4. Bring down a 0. So at this point, hopefully you see that 40 is going to repeat, and that pattern is going to continue. So that means your answer is 0.166. And this 6 goes on forever until the end of the world. It never stops. So the way we indicate that in math is with bar notation, and that's showing the 6 is continuously repeating. So in the chart here, what we're going to do is organize fractions and their corresponding decimals according to their type. So we're going to use all the numbers from 1 over 1 to 1 over 9. Okay? So we're going to start with 1 over 1. And I'm going to place them here as we go. So 1 over 1 is actually going to be terminating. If we write that out using long division, it would be 1 into 1, which goes 1 time. And that is 1, or 1.0. But we can just put, let's put 1.0 since we're focusing on fractions to decimals. Okay, so that's terminating. That means that it stops or ends. Okay, 1/2 is also terminating. We're going to put 2 out, and then 1.0. A long time ago, when I was first learning how to do this, I would often use 1/2 to make sure I set this up correctly, because I know 1/2 is 0.5. So when I set my division up, how many groups of 2 are in 1? None. How many groups of 2 are in 10? 5. 5 times 2 is 10. 10 minus 10 is nothing. So if I ended up with 0.5, when I divided, I would know that I was set up correctly. So that's just a trick that I kind of used. Not a trick, but something I used. Alright, so a repeating would be 1/3. And again, I just kind of know these, so I'm just writing these down to show you some examples as we go. So this is non-terminating. It repeats. And how many groups of 3 are in 1? 0. How many groups of 3 are in 10? 3. 3 times 3 is 9. 1. You can bring down those zeros after the decimal forever. So how many groups of 3 are in 10? 3. 3 times 3 is 9. Okay, so hopefully you see, that's repeating. So what's going to happen is you get 0.3, and the 3 just repeats forever. Okay. I'm just going to white this out so that I have some more room. Okay, we did 1/3. We're going to do 1/4. 4, into 1.0. 4 into 1, how many groups of 4 are in 1? 0. How many groups of 4 are in 10? 2. 2 times 4 is 8. 2, bring down a 0. How many groups of 4 are in 20? 5. 5 times 4 is 20. So 1/4 is 0.25. 1/5, afraid I'm going to run out of room here. I'm just going to write 1/5 here and say that is 0.2. And you can work out the division. I'm just kind of running out of room, maybe time as well. Okay, so we did 1/6 up here. That was 0.16, and that's repeating. 1/7. Ooh. Work out 1/7. But instead, I'm going to show you 1 divided by 7. Okay, so I don't see anything right away that might be repeating, but then when I look a little closer, I see here that this 14 could be repeating. So I could work this out on paper, and so to save us a little bit of time, I'm just going to use this online calculator, and I'm going to show you 1 divided by 7. Execute that, and then here it tells you the answer. And if you look, 142857, 142857, 142857, and that's going to continue. Now at the end, it does say 9, but the reason it does that is because the calculator can only fit so many digits. So at the end, it's rounding this 8 up to a 9. But that pattern is going to continue or repeat, which means 1/7 goes here. And I'm going to go back and grab that pattern. 1, 4, 2, 8, 5, 7. And then it starts over. So right here, all of that is repeating. So that bar notation goes over every bit of that. Now we're going to do 1/8 on this calculator as well. Feeling a little pressed for time. Okay, and that's 0.125. So 1/8, 0.125, and that did stop or terminate it. And then 1/9, that's going to 0.1 repeating for 1/9. So not 0.9, 0.1, 0.1 repeating. 1/10 we can do is 0.1, and that one terminates. So there's that page. Hopefully you've got these things down, and we've looked at a little bit of the division. So we have this laid out very nicely. Just 2 more examples that are written in a very organized fashion, pointing out that the denominator is here and the numerator is there. So this would be 1/4 equals 25 hundredths, and this would be 2/3 equals 6/10 repeating. So we have another example where to convert this using long division. So we have -3/4. I'm just going to go ahead and stick my negative sign there because I know that's going to be negative. And for the decimal, I'm going to go 4 into 3.0. So I'll think out loud here. How many groups of 4 are in 3? 0. How many groups of 4 are in 30? 7. 7 times 4 is 28. Subtract that. 2. Bring down a 0. How many groups of 4 are in 20? 5, because 5 times 4 is 20. And this is my end result. So you're going to do each of these using long division. Go ahead and do this one with you. Have a negative result, 8 into 7.0. 7 times 8 is 56. 8 times 8 is 64. Bringing me 6. 0. 7 times 8 is 56. 4, bring down a 0. 8 into 40 goes 5 times. 8 times 5 is 40, and that is done. 16 into 3. I'm going to pause that. Well, let me just switch colors. Okay. 16 into 3.0. 0. That would go once. Get 1, 4. Move down a 0. Okay, so I'm going to do a little side work. 16 times 5, 0, 380. It's probably not enough, so let's try 8. 6 times 8 is 48. 8, 9, 10, 11, 12. Okay. Let's do times 9. 9 times 6 is 54. Okay, so that's a little too much, so I'm going to go with 8 and 128. Subtract that. That leaves me with 12. Bring down a 0. 120, probably be 7. Okay, so 16 times 7. Okay. Probably end up with 2 videos here. Okay, 6 times 7, 42, 4, 7, 8, 9, 10, 11. 7 times 16, 8, down at 0, that's 5, I've already got that on the side, and that's 80, so that's done. So that would be 0.1875, or 1,875 10,000ths. Okay. So I'd like for you to work out this page on your own and then play again after you've worked it out to compare your answers. Okay, so we had previously done this example, and this one is worked out here. You may want to pause it and compare your work to mine. Notice I've highlighted here whenever I recognized it was going to be repeating. They're not all repeating in life, but these particular examples were repeating. We've already done some that are not repeating previously. So I indicated when I knew that they were going to repeat. So again, you may want to pause this and look more closely, compare my work to your work. So in lesson 13, there is a way of looking at the breakdown of the denominator to determine if a fraction will repeat or terminate. For this, we're going to say we can tell if there's a pattern or if it stops. Okay, so we can review lesson 13 for specifics or look at the pattern when long dividing. Okay, here we have $8 divided amongst Eric and his 4 friends for a total of 5 people. And I've done my division here. And even though that ended, since we're talking about money, money has 2 decimal places, so I've added a filler 0 at that point. So if 2 people left, we see now we're dividing the $8 among 3 people, which would be, and the 6 is repeating, but when we're talking about money, we don't pay repeating amounts like that. We would have to actually look closely and think about it. That's going to be $2.67 because they're not going to take less than the total. And if we just paid $2.66, we wouldn't have the whole $8. So you can work on your problem set now. Thank you.